Hello, welcome back once again. Today we have another interesting indefinite integral involving trigonometries. We have to integrate the cosine square of x minus the sine square of x whole divided by 1 plus the cosine of 4x dx. Okay? Now before we proceed, let's call this integral I, right? Then we're going to make use of some trigonometric identities. We know very well that the cosine squared of x minus the sine squared of x is equal to the cosine of 2x, right? We're very familiar with this. Then again, we need to manipulate this denominator, okay? But before we do that, let us record the following. We know that the cosine, the cosine of 2x is equal to 2 multiplied by the cosine squared of x minus 1, right? Now, let's think about the cosine of 4x using this idea. So the cosine of 4x is equal to the cosine of 2 multiplied by 2x, right? So this is going to be equal to 2 multiplied by the cosine squared of 2x, right? You know why? Remember here we have this 2x. Sorry for that. Okay, so remember we have just x here and we have 2 multiplying x. So in this case, our x will serve as 2x since we have this 2 multiplying this 2x. Did you get the idea? So anywhere we see x here, we replace with 2x. So that's why you're saying 2 cosine squared of x, and here we're saying 2 cosine squared of 2x. Did you get the idea? Okay, then what is next? Then we're subtracting 1. Then our integral I, which is equal to the integral of the cosine squared of x minus the sine squared of x divided by 1 plus the cosine of 4x dx is going to be equal to the integral. So up there we have just cosine of 2x, then divided by 1 plus, so here we're going to have 2 cosine squared of 2x and then minus 1. And then we have our dx. This is interesting, right? Okay. Now, remember we have some nice cancellations, right? We know the positive one and the negative one. We get rid of that. So our I is equal to the integral of cosine of 2x, then divided by 2 cosine squared of 2x and then dx, which is equal to 1 over 2, right? The integral of, so we know with the cosine here, 1, and here reduce this to just cosine of 2x. So here we just have 1 over cosine of 2x. And then we have our dx. And we know the obvious relationship between the cosine function and the secant function, right? We know the cosine function is equal to 1 all over the secant function. So in this case, we have the reciprocal of the cosine of 2x. So that is going to give us the secant of 2x. So we have 1 over 2 multiplied by the integral of the secant of 2x and then dx. So let us make the following substitution. So we're going to let t equals 2x. Divide both sides by 2, we get t all over 2 is equal to x. Differentiate both sides, we get the t over 2 is equal to dx. So here we get I is equal to 1 by 2. The integral of this is going to be the secant of t, right? That is sect. Oh my god, that's crazy. Then our dx here is going to be the t over 2. So the 1 over 2 is going outside. So this is going to be I is equal to, this is going to be 1 all over 4. Then the integral of the secant t and then dt. So we know the standard integral formula for the indefinite integral of the secant function. So this is going to give us 1 all over 4, right? So we have 1 over 4, then we have the ln of, this is going to be the secant of t plus the tan of t, which is tan, and then plus c. So don't forget our initial substitution, which says that t is equal to 2x, and boom, we're done, right? So here our I is going to be equal to 1 by 4. The natural log of this is going to be the secant of 2x, then plus the tangent of 2x, and then plus c. So this right over here is our solution. If you really enjoyed the video, do one thing, kindly support the channel by subscribing. You can also like, comment, and share.